And it is not only surface. If you can also add ion column in an electron microscope. I think most of you would have heard about scanning electron microscope for sure. But on the same scanning electron microscope, if you add column, the ion beam can be used for removal of material. So as you can see here, the region of interest was identified in an anode. It's a lithium anode, and you can see the material is removed using the ion beam, very particularly on the precise region of interest. The material is removed, and you start the roll or the mechanism of the battery material that is being made. And yes, of course, then it can be subjected for various chemical characterizations as well. And it is again not only in two-dimensional, all the characterization technique have already started moving towards three-dimensional characterization. No more two-dimensional is being considered as the complete understanding of the functional behavior of material. So we are all talking about three-dimensional characterization that is equally possible by non-destructive as well as destructive. Destructive is very simple. The ion beam is used for removing the material. Subsequently, the electron beam is used for capturing the image. So they go in serial. So removal of one layer, capturing the image. Remove the next layer, capture the image. You stack all these images one over the other, and you do a complete 3D volume rendering, and you get the three-dimensional data sets. So to conclude my presentation, again, so we have this complete suite of microscopy techniques irrespective of your application domain. I just took battery because one of the area of focus for the conference is on the energy materials. I took battery as one example, but this can be applied irrespective of whatever research domain you are into. So I have this practice of saying this: microscopy techniques, except for, yeah, no, I cannot even say economy. Except for politics, it gets into every subject that you guys are into. Yeah. So that's the influence and importance of microscopy that can be deployed to any field of research. In the interest of time, I'm just concluding my presentation, and I open the forum for any questions. So, no questions. Thank you so much for your patience and giving me an opportunity to present what we do at Sir. Thank you so much.
Thank you for your powerful words, sir. Now I would like to invite Mr. Manimaran to provide the guest of honor.
Get set for an explosion of knowledge as I introduce our next speaker, Dr. Nagaswarupa HP, Professor and Chairman, Department of Science and Chemistry, Shivagangodri Dangri University. He holds his Master in Chemistry from Bangalore University in 2002 and completed his PhD degree in 2012 from Bharatidasan University, Trichy. He has been teaching chemistry for UG and PG levels since 22 years. He has published 199 research papers in reputed national or international journals, edited 10 books, authored
Good afternoon. Just before the lunch, being a last speaker, I know that everybody's attention is towards the lunch. And the given time is 10 minutes. Let me now try to complete the things within the 10 minutes of time. And straight away, without wasting much of your time, I skip all these things and, you know, uh, all this based on, you know, straight away, I just go to the work what we have done here. Majorly, I just like to, talk on the trimetal, ones, the nanomaterials and their applications in various sectors, especially focusing on the the wastewater treatment as well as the sensing applications. Here, we have, focused on synthesizing the materials like copper zinc aluminate, especially by the solution conversion method. Okay, and by taking the suitable nitrates as well as the urea and other green sources as the fuel, is developed this one. And the particle size of these things we have ended with somewhere around the 40 nanometers. And these copper zinc illuminates, when we done the UVDRS analysis, having a particle size of 5 electron volts. And by using the other techniques like SEM and TEM, we even able to characterize them, their surface morphology and things like that. And when they are used for the wastewater treatment, especially for a dry degradation for this acid red and 88 dye, we could able to find out for this dye somewhere around 91% of degradation for about 20 minutes under the UV sunlight. And even we could able to do the recyclability and reusability test also. And at the same time, the effect of various scavengers like silver nitrate, alcohol, and EDTA, and we could able to get a good degradation results of somewhere around 90%. This is what the proposed mechanism, as well as we can able to use some electrochemical studies using the cyclic voltammetry and equivalent measurements and all for the sensing of the heavy metals like the lead and the tin. And these are the good electrode materials for especially the sensing of these heavy metals in various samples. And these results were published over there. And the one more material that is the bismuth magnesium ferrite, again a trimetal one. Okay, by two different approaches, green as well as the chemical approach, we could able to synthesize by the same again urea as well as aloe vera gel. And here, what we can observe is actually after the XRD analysis for the the chemically synthesized one somewhere around 25 nanometers and the grade one somewhere around 18.5 nanometers we could able to get it. And the band gaps were also we could able to estimate somewhere around 2.89 as well as the 1.39 electron volts. By making use of these things after their analysis by other methods, uh, the degradation studies for the different dyes, and we could able to get a good degradation with respect to these green ones, green root synthesized one by aloe vera, so around 74% and 85% of degradation with respect to the chemically synthesized one using the urea as a fuel for the development of these things. And to know the stability even after the degradation, we have done the XRD analysis also. And this seems to be the result seems to be telling that the compounds were quite stable. And to know their ecological impact analysis by the plant growth and degradation methods, try to know their impact on the plant growth as well as the seed germination by taking use of the control and the uh, degraded water and the dye water. A similar matching results for Octane with respect to the degraded water compared to that of the controlled one. And these results were published. And the one more material that is calcium magnesium titanate. Again, by using the urea as the fuel, we could able to design by combustion method, okay, which gives an particle size of somewhere around 41 nanometers, and the particle size of the band gap, which is obtained, is around 3.2 nanometer watts, and the SEM and EDAX study shows a grain-like structure with a good combination. Okay. And again, for the same time, the degradation rates obtained were somewhere around 75%. And the same product is been used for the impact studies by Bangalore, as well as the sensing applications against the important biomolecules like creatine and the ascorbic acid. And based on the various, properties, the clinical properties, we were able to, use these materials for the different applications like, the wastewater treatment, that is a dye degradation, and various sensing of heavy molecules, heavy metals, and the biomolecules, and even we could able to do the other sensing applications also. Okay. To conclude, okay, we can go for designing the various trimetal hybrid nanomaterials, which can be used for varieties of applications, okay, like wastewater treatment and the sensing applications, as well as antimicrobial studies and even the living science applications also. Due to the time constraints and the other things, actually, I just stick down the things and share it. Thank you very much.
Thank you so much, sir, for sharing your insights and spending your valuable time with us. Now I request Dr. Anita ma'am to honor the guest. The participants who are presenting in this venue can stay. Rest of the audience can move for lunch to canteen. It is arranged in ground floor. Thank you.
everyone பார்க்கறது இது சைன் பண்ணல நான் சார் இங்க வென்யூ ஒன் யாரு வந்து பண்றீங்களோ லஞ்ச் முடிச்சு 15 மினிட்ஸ்ல வரணும்.